All right. So we will be getting to preview quiz 5. Just not quite yet. So that can get out of the way. We are going to be dealing with these, I have a feeling, at the start. But first, this particular lesson brought to you by, you need to come for the half ACT. Okay, again, next Thursday or Saturday. 2 hours, well worth your time to know what strategy sessions you need to be attending later in March or early April. You don't even have to go to the counseling office anymore. There is a sign up on the door. Now, if you're watching this at home, it doesn't help you to sign up on your door. But if you're in class, it does.
Well, you kind of did it the wrong way. LOL.
Well, it's where I'm sitting right now, and to me, it's that way. So, oh well. So sign-ups will stay there through early next week so we can get this figured out. Extra credit to boot. I'm going on extra credit fire. End of message announcement. Okay, so what do we need to tackle from yesterday's business?
Let's just do number 2.
They're like, let's just do number 2. Let's just do number 4. Let's just do...
Number 2 and 4.
Jeez.
I just got them all wrong.
Okay, now here's my question. And I'm on the SAS side because I know there's a number 2 and a number 4 on both sides. The other side, number 2.
Yeah.
Okay, I will get to the other side, number 2, in a minute. Let me go to this side, number 4 first. Now, is the deal here that we don't remember our properties of parallelograms? This is where I should see heads nodding, probably. Uh-huh.
I memorized them all.
Okay, so the sides of the parallelogram have lengths of 18 and 26. Now, to me, just visually looking at it, okay, 18 and 26. And one angle is 39 degrees. Now, again, think about how a parallelogram works. You're going to have 2 obtuse angles that are greater than 90 and 2 acute angles that'll be less than 90. Well, they're telling me one of the angles is 39. That would be acute, so I'm going to assume that's probably 39. So here's the question. Find the length of the longer diagonal. You're like, well, how do I figure out one's the longer diagonal? The one that runs with your longest side. So my longer diagonal would be right here. So you're like, ooh. So does that diagonal cut the angle in half? No, I can't assume that. That's not a property of parallelograms. Well, what am I going to do then? Because the 39 is kind of useless when I'm cutting it, into some piece. Well, no, we can't assume that. We can't assume that that is being bisected. But here's what we can do. One other property of parallelograms is their consecutive angles are supplementary. Oh, geez. What's supplementary mean?
Equal 180.
Equals 180. So if consecutive angles here equal 180, is there a way I could figure this out and maybe use it? Yeah. So if I kind of figure that out, what's this angle going to be? 141. You're like, so wait a minute. So I'm not actually going to use the 39 anywhere in the problem. Correct. The 39 was giving you information so I could find this other piece. Because now that I have this, I have an angle, and I have 2 non-corresponding sides, so I have to use the law of cosine. So again here, since this is what I'm looking for, x squared, my missing side, is going to equal the sum of the squares of the 2 sides that I have minus 2 times their product times the cosine of my angle. And that's how that one runs through. Because at this point, I can type all of this into my calculator and then just take the square root, and that would give me the length of my diagonal.
That 148?
141. Oh. So, I mean, yeah, you're like, dang, I actually have to remember the stuff I had in geometry? Yeah, for some of the stuff, because Trig Trig has a much closer relationship to geometry, just like college algebra, of course, has more of a close relationship to algebra. So yeah, that geometry stuff, if you're a little shaky, probably a good idea to
Look up.
kind of go back and check some of that stuff out. But again, you can handle the rest of this because, well, you can.
Oh, Mr. Hardy,
Yeah.
you know what I took yesterday? Acupuncture test. And I aced it. Awesome.
All right. I'm off.
Get the jagged advance on my calculator.
All right, let's come back here for a second. Two things that I'm going to make sure of before I continue too far here. All right, first, make sure one of my darlings has not put your calculator into radians. That's the first thing to check. Once we're sure that's the case, once I start typing all of this in, I want to pay close attention to make sure, like, I'm not getting a plus instead of a multiply somewhere, you know, that I'm using sine instead of cosine in this case. Okay, anything like that. So make sure that's looking good. Okay. And then again, that's the squared version of my x. I want the square root of it.
I didn't even get that. I got like negative 49.
I second that. Okay. So, heading to the other side though, because did I hear 2 on this side? Okay. So 2 back over here. Let's see what we got. All right, directional stuff. I can understand this too. All right, Sarah Phillips, an officer for the Department of Fisheries and Wildlife, checks boaters on a lake to make sure they do not disturb 2 osprey nesting sites. She leaves a dock. Okay, here's my dock. And heads due north, in other words, up, okay, in her boat to the first nesting site. From here, she turns 5 degrees north of due west. Okay, little lesson on directions. Due west would be straight to the left because, well, that's where west is. But she's 5 degrees north of that. So if she would have gone due west, it'd be a 90-degree angle she made. But it's not. She's 5 degrees north of that, which means not only do I get the right angle, I get the 5 extra degrees. So sort of like the parallelogram, yeah, they don't tell me this 95-degree angle, but that's what it is. So she, on that path, she goes 2.14 miles to the second nesting site over here. She then travels 6.7 miles back to the dock. How far from the dock is the first nesting site? Now, here's the thing that was really kind of not nice about this. I put this on a Law of Cosines page, and, well, it's law of sines. So, but that's something good because it makes us have to think, okay, I have a corresponding angle and its corresponding side. So I'd have the sine of 95 over 6.7. Now, here's where I start to look and I say, okay, so what am I going to do for my second fraction?
Sine of x over 2.4.
Now, here's the question though. No. I don't know if I'd use x because then I'm going to think this. So I'm just going to call this, let's see, call this d. So the sine of d over 2.14. So I'm not going to get what I want right away. I'm going to have to take one extra step here because to get this right away, I have to know that angle, and I don't quite yet. So let's pop this up. Clear it it up. Again, take my diagonal that doesn't have my d in it. Divide by my number in my side d here. And again, since I'm looking for an angle, I need to take the inverse. So second sine with that funky decimal. So d is about 18.6. So I can get that jotted in here. And now I can at least get my other angle so I can find what I'm looking for. So here, I'm just going to quickly do, as I move this over, 180 minus the sum of 95 and 18.6. 66.4, and thankfully we are almost there. Sometimes we have to do a little more work than we'd like. So again, my last part, take that original part that we've got, so my corresponding side and angle, and now I know my angle, I need to know what the side's going to be. So 6.7 is the side. And divide by the sine of 95. And we find out we're about 6.2 miles to get to that first site. Let's see, and that's what we were talking about a little bit yesterday when we started at the beginning of the class talking about how do I know if it's law of sines or law of cosines. It all depends on what information you have as you're drawing. Here, for instance, I had a corresponding side and angle. That always directs me to law of sines every time. If I have three sides, if I have two sides, but the angle doesn't match up with one of them, that's when I've got to play the law of cosines game. And that'll happen every time with these, even if you change things up just a little. So like for instance, some of you said something about 4. I'll help with some setup here. But again, add your pieces in as you find out. Island A is 220 miles from Island B. Okay, 220. A ship captain travels 320 miles from Island A, then finds off that he's off course and 150 miles from Island B. So he's going along up here, 320, and then he goes, oops, I need to get over here. I'm kind of off. I'm still 150 miles over here. Yeah, the dotted line, and let me explain how that can kind of work. It depends on how you're looking at things. Sometimes they'll look at this, and they'll have you find the angle over here and then find the supplementary, which I've never quite understood that whole concept. So when I go here to turn, I'm going here, I go, oops, crap, I screwed up. Okay, here's what I'm actually on the lookout for. Now again, this isn't preferably what I would like it to be, because when I go to use law of cosines here, because I have three sides, which side do I have to use first? I heard it in the back. I've got to use B here first, because when I'm doing law of cosines, I have to use the biggest one. So I do my side B squared, because I'm going to end up finding the cosine of B. Again, is the square, the sum of the squares of my other two sides, my shorter ones, minus 2 times their product, times the cosine of B. Now again, that doesn't make me thrilled because, well, dang it, I just want that. Well, I can't quite do that yet. So again, we crank this out. Now remember, from what we were saying yesterday, this needs to be done in pieces. So I'm going to get my first number squared. Then next I move to this part. And then I deal with the part that's attached to cosine of b. Because again, we're going to treat this like an Algebra 1 problem where we're trying to solve. That cosine of b is attached to the 66,000. Do not subtract those. I'm treating this, again, sort of like this is 102,400 equals 70,900 minus 66,000x. If that were the case, we wouldn't do that. We'd minus the 70,900 out of there first. And get that set. And then that value that's attached to my cosine of b is what I'm going to divide by. Now, at this point, we'd said yesterday, you can either put it into a fractional form or if you go to the decimal, which is fine. At this point, I'm going to take that decimal and its cosine, and I'm looking for an angle. So second cosine, I take the inverse of that answer I got once I divided, and I find out that b is about 118.5 degrees. You're like, wow, that'd be enough if that's all I had to do. But unfortunately, it's not. Because now I do have a corresponding angle and side, so I'm going to get to use the law of sines. But, oh, which angle do I have to find?
A.
Yeah, because I have to use the smaller number. Bigger in law of cosines, smaller when we do law of sines. You're like, crap, Hardy. No wonder you only gave us like 4 of these that we had to do. They take forever. So now, okay, that was my first step. Second, I've got the sine of 118.5 over my corresponding side. And as we said, unfortunately, we have to deal with the shorter side here. So 150 over the sine of a. But then we will have our last step, which will be easy to work with. So again, pop the calc up. Cross multiply again. The one that doesn't have your a, we'll multiply those together first. Divide by the number that is being multiplied by the sine of a. And again, we're looking for an angle, and we're in sine now. So second sine, inverse of sine. And my answer, so a is 24.3. So finally, we have made it to a point now that it will be simple to find x, the angle we wanted to begin with. We have a triangle, so it's 180 minus the sum of those other two. Yowzers. Gracious. Now see, to me, if you haven't, since basically we did the homework now, I'd take advantage and go back and do all the extra credit. Uh-huh.
Yeah, because I was confused about that one.
Okay. Let's set this up.
They said they left the same spot, traveling different directions at the same time.
Okay.
I went like...
So we started here. 2 cars moving from the same location. They head straight but in different directions. Okay. Bang. There they go. The angle between where they are heading, this angle that gets formed, is 43 degrees. The first car travels 20 miles. Second car travels 37. How far apart are they? because then I've got my angle on my two non-corresponding sides, so I'd use the law of cosines with that.
You sure?
Positive.
You're right.
Because where my x's is where one of my numbers would have to be if I wanted to use the law of sines. Okay. So, they're like, oh boy. With that big warm-up, shoot, I think this quiz preview is going to be a piece of cake once we've gone through all of this. So what I'm going to do now, for those of you waiting at home that are like, oh my gosh, he's 20 minutes in and he hasn't even started this yet. That's okay. We got this. All right. Quiz preview. Now, you'll notice, and whatever I do on the quiz, I do on the previews as well. So if one of your issues has been dealing with, is it sine, cosine, or tangent, yes, this will be there. Okay, the SOHCAHTOA. So that should help with some issues here. So when we're doing these, let's get them set up.
Okay, wait. I have a question.
I mean, okay. So, for number one, which sides do I have to work with? Try to ignore the fact that that's got hypotenuse and opposite. You're like, wow, it's been a while since we did this. Right. I've got opposite and hypotenuse, which tells me I don't have sine. So the sine of 52 is opposite over hypotenuse. And again, I would just multiply by 40 to get the x by itself in this case. So basically it's 40 times the sine of 52. Bingo. And again, we've always been going to tenths lately, so we'll just keep doing that. So as we work our way across on these, that's going to be my setup. But number two gets a little more interesting. Okay, what sides do we have to work with in number? Adjacent and hypotenuse. So which cosine? Here's something some of you are going to have to be careful of. Okay, this one doesn't set up quite the same way as number one because the number isn't in the denominator. So instead of multiplying 40, like we did here with 40 times the sine of 52, if x is in the denominator, you actually divide. So for this one, I'm going to end up with the cosine of 37 divided by 85. And that's if the denominator ends up being x. Here we ended up multiplying them because the value, the 40, was in the bottom. And you have to watch for that because the answers will be different, of course, whether you divide or... Now, what did I just do?
Wouldn't it be 85 divided by the cosine?
Oh my gosh! Grr to me. Because even if I would have thought it was that when I wrote that down, when you got to the answer, I'd hope you'd look at that and go,
Yeah,
a side is 0.009? That doesn't make any sense. Let's flip it around. That's better.
The book works too, right?
Okay. So, let me shrink this back down. For the moment, I'm going to jump around a little bit because I just want to make sure that we get everything. I still think we're going to get through this whole thing, but I want to make sure. So I'm going to come down to number 5. All right. Ooh, we get to draw. We get to see my awesome drawing skills. A building casts a shadow of 46 meters when the angle of elevation of the sun is 25 degrees. How tall is the building? Okay. Here's my building. I know, it's impressive. Casts a shadow of 46 meters because think about it. When you stand somewhere and you can see your shadow, the shadow's showing up on the ground. Okay? So that's how I know this is where the 46 goes. I also know it's going to end up being a triangle, so I'll get that in. When the angle of elevation of the sun is 25 degrees. Okay, here's my sun. I'm looking up at it. Because if it were up here, it would be what's called an angle of depression, because it's like you're looking down. If you're depressed, you're kind of down about things. If it's elevation, you're looking upward. So that's how I know where to put my angle. So how tall is the building? How is this going to set up? Tangent, because we've got opposite and adjacent. Good, good, good. Opposite over adjacent. And again, since the number's in the denominator, we're going to multiply. So what is 46 times the tangent of 25 going to be? 21.5. The preview, let's see how far we get. If we bust through 90% of this together, I might whack the preview. We'll see. Cool. Well, because again, on the previews, the main concept is we're working through them to get you ready for the quiz. So we'll kind of see what's happening here. All right. From the top of a 120-foot high tower, that's labeled, an air traffic controller observes an airplane on the runway at an angle of depression of 19 degrees. How far from the base of the tower is the airplane? Now, be careful. Notice that 19 degrees right now isn't in the triangle that I'm working with. You're like, well, what the freak? What am I supposed to do then? We get to do a quick geometry review again. You're getting all these bonuses today. This is awesome.
Is it in there?
What's that? Well, maybe. That's one route you could go. I like that thinking. If you look at it, you're like, well, this and this make a 90-degree angle, so couldn't I just subtract 19, call this 71, and work with it? Yes. Let me even give you another idea that you could use in case that doesn't click right away. These are parallel lines. Okay? When you have parallel lines that are cut with a transversal, the alternate interior angles are congruent, which means that is 19. I can use either of those, okay? And I would end up getting to the same solution. But to make sure, they're like, oh boy. Let's test this theory out. So since 71 was mentioned first, let's try that first. If I use the 71 degrees, what sides do I have? Opposite and adjacent. Okay, so I would have the tangent of opposite over adjacent. Okay, let's crank this out and see what we get. So again, my 120 is in the denominator, so I'm going to multiply. So I get 348.5 feet. Now, let's just say you didn't think of that, but you remembered this and you tried it with the 19. Let's see if it works. I've got opposite and adjacent again. You're like, well, how does that work? Because we're going to use tangent of 19. But now it would be opposite over adjacent. And we found out before when that happens, after Hardy boneheaded it, that we're going to divide by that. So let's see if we get the same thing.
Oh, nice.
Hey, hey, yes we do. Okay. So you do have options on these. It's not like, well, if I don't see that right away, I'm screwed. You're not. It just depends on which way you want to look at it. I get the same answer either way. So just kind of jump in, be assertive, and don't worry about it. like, I understand this way. That's why I put them both. If there's one way that makes more sense to you, then just use the one.
No, I just didn't.
So let's see. For 7 and 8, oh, we get triangles, but we got to draw ourselves. Jeez. All right. I always just do it this way. If you label them a different way, you'll get the same answer as long as things match up here. All right. Now, we are attempting to locate A. So, what else would be handy to know, since normally when I see a proportion being set up, that typically means we're doing law of sines. Yeah, angle B would be helpful because then I have a corresponding side and angle. So what is angle B? To be 73. Because now I have my corresponding angle and side, and I can do sine of B over the side. And since I want A, so let's see here. What is A going to be? Okay, 15.1. Because I'd do 23 times the sine of 39, and then I would divide by the sine of 73. So again, no real biggie. We're just continuing to use the parts and kind of work it that way. Now, I'm going to move around again. To the back. And yes, I know. I'm nice. You're welcome. I've got the blank set up here to help remind you with the law of cosines what's going to be going on. So once again, okay, let's get everything labeled here. So A is 6, because again, side and angle are always across from each other. Two sides and a non-corresponding angle. Sweet. If I'm looking for side C, I'm like, okay, so C squared would be the sum of my squares from my other two sides minus 2 times their product times the cosine of my angle. And again, this is one I can type straight into the calculator as it is. So as you pop that out when somebody gets there. What's that? I'm just looking to see if everybody agrees. Uh-oh. Oh, I'm hearing different answers now. Okay, wait a minute. We better check this out. All right, clear. 11 squared, 6 squared minus 2 times 11 cosine 54. But I need the square root. Oh, jeez. Okay. Yes, sir.
When you have to do the second sign or second answer, that's the angle.
Okay. So now, I'm going to move down a little bit because I can't believe somebody hasn't said something about this yet. I was ready for the freak out.
What?
When you get down to 11, we're into review mode. Oh, crap.
Logarithms.
Logarithms.
Best day of my life.
Now, remember, when we're doing logs, okay, if you are trying to get rid of a number that's a base, like we are here, okay, a number and its base log are inverses. So for instance here,
Log.
I would use the log, which we assume is base 10, right?
But isn't log based on
Just log, yes. So, by using the log of that base,
they cancel?
those are inverses. And then to get my solution, I'm going to pretend it's not just log 10, because that way we can make sure we remember how to play with the calculator here. It's the log of the big number, we called it before, divided by the log of your base. Okay, so big divided by small in physical size. And I get my answer. So in 12, it would be the same idea working. I would use the log of base 2 as my inverse. My exponent would still be left, the x minus 7. And so when I get to here, and I would minus 7 from this. So here's how I would personally go about calculating this. Okay, I remember for this part, log of the physically larger number, 12, divided by the log of my base. I would hit enter at this point, and then minus the 7. So it is, we are very much getting into a part of the course that is very much about detail orientation. And that's it. So 13, it's the same idea. I want to isolate, I want to get to my x. So, yep, I'm going to minus the 6 first. Oh, calculator in the way. Okay, there we go. What's my inverse of e?
Natural log.
Natural log. So natural log. And then the natural log of 15, get the calculator out of the way, ln, 15. Whoa. Okay. So logs and their bases are opposite. Natural log and e are opposites if I'm trying to solve. And then we get to do the easy part. Solving with logs on both sides. Log base 3, its inverse is
3.
that number, 3. So if I use the 3,
They just cancel.
those are inverses and just cancel, and I just solve the equation that's left. Okay, we're going to keep life simple. And we can solve a two-step equation, so it's really no big thing. 15 is the exact same thing. Natural log and e are inverses. Again, those inverses get rid of that and just leave you with whatever you were taking them to. So again, nothing too terribly awful. So you're like, all right, it's kind of starting to come back here. This last part then of those, solved by exponentiating. Now that's kind of a clue. On each side, round answers to the nearest thousandth. Again, keep thinking about them as inverses, but remember, exponentiating. The base word in that, the root word is exponent. When you're using the base as your inverse, you're turning what's there already into an exponent. So that's x. This isn't 4 times 5. It's 4 to the 5th power. So let that word exponentiating be like your light bulb turning on and going, oh yeah, these are going to turn into exponents. Okay, I need to get rid of ln. Well, that's e. And again, the nice thing with e is e exponentiates itself without you doing anything. So when I go to punch this in, again, e is second in natural log. See, it turns into an exponent already. So even if you forget, it's impossible to forget because the calculator's going to do it for you. Nice. And then Ben had mentioned it earlier, but if I have a log and I don't see a base number down here, what number is it? 10. So, to exponentiate, I must use 10. That just wipes the log part. But the other side still is an exponent because there's no log over there, no inverse for it. So 10 squared is 100, and now I can solve the equation. And then note the warning on the bottom. There will be fewer log problems tomorrow. There will be some. There will be fewer log problems. Those will be replaced with trig apps. So be prepared to either look at a picture, maybe sketch one, and work through that. And if you have issues with some of the other questions we didn't get completed with, we can do those at the start tomorrow if you want to do that.
So the law of sines worksheet's on there?
The law of sines is an extra credit sheet that's optional.
So on number 10, I have to use law of sines.
When you're doing number 10 up here, now you're fortunate you're not going to have to use the law of sines because which side's the biggest? 11. So you're going to have 11 squared equals the sum of the other two squares minus 2 tenths. So once you solve that, you've got your C and you're done.